For area of parallelograms, which we're going to be discussing, there's a few terms that you'll need to know. This is just a rundown for a lot of the abbreviations or letters you'll see in formulas. For parallelograms though, base and height and length and width will be what you're looking at. These are interchangeable. When you were younger, when you learned area, you usually used length and width. But now we're going to be using the terms base and height. It means the same thing, and the base and the height, or if you want to call it length and width, are perpendicular. And remember, perpendicular means they make a 90-degree angle with each other. Okay? So there has to be a 90-degree angle where the base and the height meet, or the length and the width. Okay, we're going to first talk about rectangles, which is a more specific parallelogram, and we're going to solve these out. The first one that we're given here is a rectangle with a length of 12 and a width of 2. So simply all you have to do is plug in for your base and height, or length and width, 12 times 2. So you get an area of 24. Now, if your dimensions are in centimeters, you're multiplying centimeters times centimeters, so your answer should be centimeters squared. Okay? Now, for the second one, these tick marks imply that all four sides are equal. So, in reality, this is a square, which is a more specific type of rectangle. Now, we normally use base times height, but in a square, you could say that this is called the side, so S and S instead of B and H. So B and H could be replaced by S times S, which is just S squared. So when you are dealing with a square, the formula could be written as base times height, or side squared. Okay, my side given is 5 feet, so 5 squared, which is 25. Remember, squaring is multiplying the number by itself, so 5 times 5. And don't forget to put your units. In this case, we were told that this is feet. Area is squared. Okay, in this third one, you're given a base and height of 3.2 inches and 15.4 inches. It really doesn't matter which you call base and which you call height, or which you call length and width, because when you multiply, you get the same answer no matter which order you put them in. Okay, so then you would pull up in your calculator. These you could do in your head. This one you would probably need a calculator for. So you would do 15.4 times 3.2, 49.28. Now, I say you would use a calculator, but you could do this by hand if you're not given a calculator. You just have to remember when you're multiplying with decimals, when you get your final answer, to move that decimal 2 places. So it's come over here to 49.28. And this was in inches, so it is inches squared. Okay, now for our parallelograms, the area of a rectangle comes from parallelograms. It is base times height. Okay, but in a rectangle, it's easier to identify your base and height because all 4 angles are 90 degrees. But in a parallelogram, these angles of your parallelogram are not 90-degree angles. So the sides of your parallelogram are not technically your base and height. So to get the height, you have to drop down a vertical line that makes a 90 degrees with your horizontal base. Okay, once you have that length, that is your height. Okay, this is marked all 4 sides congruent, so this is a rhombus, and the height of our rhombus is 10. The base would be 12, because if this is 12, this is 12 in a rhombus. So you would plug in 12 times 10, 120, and our units, or meters, so this is meters squared is the area. For the second example, this one is not a rhombus. Not all 4 sides are equal, but we do know in parallelograms opposite sides are equal. Okay, so this would be 5, then this is 5. Okay, and so here, the entire length of this base is 14, and they tell us that this short piece is 3. So you can find the remaining length by taking 14 minus 3, which would be 11. Okay, in this problem, we don't happen to need to know that, but you will need to know that that's a possibility, okay, because opposite sides would be congruent, so we know this whole length should be 14. If we've already used 3, you're left with 11. Okay, now for the problem that we're asked, which is area, okay, base times height. Okay, the base is the entire length, so 14, and the height is what makes a 90-degree angle, so that is this height here. Okay, we don't know this height, it's not given. We need to find it before we can plug it into area. What we've created when we draw the height in this 90-degree angle is a right triangle. And in a right triangle, if you know two sides, you can find the third using Pythagorean theorem. So in a right triangle, across from the 90, that's your C. Okay, and then these are A and B. So when I plug in, I will have 3 squared plus h squared equals 5 squared. When you move your 9 over, you get 16, and then you have to take the square root to get rid of this. Square root of 16 is 4. Now, if you had memorized your Pythagorean triples, that'd be very quick. It's a 3, 4, 5. Okay, so now we can plug our height in. Okay, and when you do 14 times 4, you get a grand total area of 56. Our units were in yards, so this is square yards, or yards squared.